My name is Kevin Perry, and I am the chair of the Department of Atmospheric Sciences at the University of Utah. My research specialty is in the area of air pollution, and I've studied everything from the local impacts of fireworks to mercury transport and deposition to the intercontinental transport of dust from Africa to the United States or from Asia to the United States. And what I'm here to talk about today is trying to understand the dust that's actually in your museum environment. And one of the very first things you have to do is determine if you have a dust problem. One of the easiest ways to do that is to actually do the touch test. We've all done this at home. You run your finger across the desk or across the counter and see if you pick up dust. One way to systematically do that is to actually buy a Petri dish. Petri dishes are clean. You can basically open it up, lay it on a flat surface, and allow it to collect dust over a period of a few weeks to a month. And when you're done collecting, you put the lid back on, and you have a record of the dust that was actually being collected during that time period. You can shine a flashlight on it and see what you collected. And you can, because these are small and unobtrusive, you can actually put these at multiple places around your museum. And if you have a significant problem, then you have actually also collected a series of samples that can then be used to look at the chemical composition or the makeup of the particles themselves. So, if you do have a dust problem, the most important thing to do to try and remediate the problem is to understand whether or not your dust is coming primarily from outside and being transported into the museum through the heating and cooling system, or whether or not you have activities inside the museum that are actually causing the problem. Because you can understand that the remediation for each of these two different types of problems would be very different. So let's talk about particles and what types of particles are actually contributing to your dust problem. So in atmospheric sciences, we like to refer to particles as either coarse particles, which are very large. In our parlance, that would be greater than 2.5 micrometers in diameter, which is still exceptionally small. And then we have fine particles, which are smaller than 2.5 micrometers in diameter. The coarse particles will fall out of the atmosphere within a few days. The fine particles will stay suspended in the atmosphere for several days to a week or more than that. And so they're less of an issue with regards to dust deposition than the coarse particles. So the key to understanding your dust is actually understanding the source of the coarse particles that are inside your museum. And one of the easiest ways to do that is to use an instrument to actually count the number of particles that are in the air inside your environment. What I have here is a particle counter, and they all work on about the same system. They will suck the air in through an inlet, they will humidify the air, in this case with alcohol, and then they will shine a laser beam on those particles and count the scattering events that come off of those individual particles. If I were to take this outside right now, it would be common to see particles in greater concentration than more than 10,000 particles per cubic centimeter. Cubic centimeter is about the size of a sugar cube. And that's normal. If you happen to be near a highway, you would expect more than 100,000 particles per cubic centimeter. Most of those particles, though, are really small. They're great in number, but very small, and don't contribute to your dust deposition problem as much as the coarse particles. Now, most of these particle counters come with multiple inlets that will allow you to look at either the fine particles, which are the small particles, or the coarse particles. And you really want to identify how efficient your heating and cooling system is for the transport of both the coarse particles and the fine particles. So you want to take measurements inside, and then you want to go outside and compare the results. Most modern buildings will have a efficiency of about 50%, which will be removing 50% of all the particles from the air as the air moves through the heating and cooling system. For a brand new building that has a high efficiency heating and cooling system, you could expect that they might be able to remove 90% of all the particles and only have 10% get through, and that almost all of the coarse particles are gone, and the 10% that make it through are those fine particles, which aren't going to contribute much to your pollution problem. So the other nice thing about this type of sensor, and there are low-cost sensors that are available for a few $100s. This happens to be a research-grade particle counter that costs several $1,000s, but they are available for a few $100s that are robust and reliable and are good enough for this purpose. What they can also do is they can also track the pollution throughout the entire day and for weeks at a time, so that you can see if there are patterns in what the pollution concentrations look like inside your museum. For example, it's possible that patron activity inside the museum would cause a spike in pollution every day during that time period. Or maybe there are cleaning activities that happen at night that could cause a spike in the pollution. And it's important to know that, because you have to know the source of the particles if you want to try and then remove them. So what happens if you've done this measurement and you're dominated by outdoor air pollution? Then you don't have many indoor sources, and most of the pollution that's getting into your museum is coming from outside sources through the heating and cooling system. Well, the very first thing you need to do is to, first of all, make sure that you don't have air that's bypassing the heating and cooling system. If you have windows in your museum, make sure that they're sealed so that you don't have drafts or the transfer of particles directly from the outside to the inside. If you have no windows and the only airflow into the system is through the heating and cooling system, if you see a large number of coarse particles that are coming through that heating and cooling system, it could be an indicator that the system needs maintenance, or that there are pathways for air that are flowing around the filtration system of the heating and cooling system. That not being an issue, if you want to do something else, you can add filters to the exit ports for the heating and cooling system. And the type of filter that you'd like to add would be a HEPA or an ULPA filter. These are high efficiency filtration that remove more than 99% of all the particles. The problem with that in a museum environment is that they can actually restrict the airflow, which may limit your ability to control temperatures in certain rooms, which might be undesirable. So you might have to work with the building and maintenance crew to find a happy medium between filtration and airflow. So there might be a situation where the heating and cooling system is doing a really good job, and you're noticing from the particle counter that all of your particles are happening when there's activity going on inside the museum. That's an indication of an indoor air problem. And so the things that you need to do there are to identify the specific activities that are generating the dust, and then you can try and minimize that. So if it happens to be cleaning activities at night and people are vacuuming, and that's when you see your high concentrations, you need to make sure that all of those vacuums are actually using HEPA or ULPA filtration systems. If the concentrations are peaking during the day when you have a whole bunch of patrons that are moving through, do you have carpet on the floor? Carpet on the floor is a huge source of particles to the atmosphere. If you've ever seen Charlie Brown and the character Pigpen, Pigpen walks around and there's a cloud of dust that follows him around. Every single one of your patrons is generating a cloud of dust that follows them around as they move over a carpeted surface. And so that can be a big source of particles to the atmosphere. If you can't clean the atmosphere that's coming into the system from putting filters on the ventilation system, once the particles are in the air, or if they're being generated inside the museum, your only choice to try and minimize the problem is either to get rid of the carpet or to install some type of active filtration system. There are several different types of systems. There are filter-based systems that pull air through and collect the particles on filters. There's an electrostatic precipitator system that actually charges the particles and then collects them with static electricity, which is also high efficiency. But given the size of some rooms and the capacity of the filtration systems, that may or may not be practicable in your particular situation. So let's see exactly what happened at the Woodbury Art Museum. So I took this system down to the Woodbury and measured the indoor and outdoor air particle concentrations and discovered that about 50% of the particles we're actually making it through the heating and cooling system, which means that it's a modern system but not a high efficiency system. What I did discover is that very few of the coarse particles from outside were actually making it inside the building. So that meant that the coarse particles that were observed inside most likely were being generated indoors as opposed to be coming in from the outside. So that means that the dust problem that if they want to try and remove the dust from the atmosphere, they have to look at indoor activities or indoor filtration devices. So what we actually determined, in addition to just the number concentrations of the particles, we also measured the chemical composition of the particles. And this is the interior of an 8-stage rotating drum impactor. Particles enter in up here and they impact on a rotating drum. The large particles impact here. Smaller particles make it through, they impact here. Smaller particles make it through, impact here, and it goes so forth until you end up with the really fine particles here and the coarse particles here. We then took those particles on substrates, loaded them onto a slide frame like this, and took it just up the road to the Lawrence Berkeley National Lab, where we bombarded them with X-rays in order to determine the chemical composition of the particles along the way. This is way overkill for what you'd normally do, but it was fun for me, so I wanted to see what the particles were made out of. And what I discovered is that the particles in the fine fraction were very similar in composition to those that were outside. The Woodbury Art Museum was not generating a large number of small particles that were different in chemical composition than outside. So the Woodbury definitely had an issue where it was being dominated by outside transport of particles into the museum itself. And so the heating and cooling system turned out to be about 50% efficient at removing particles from the atmosphere. It was removing more than 80% of the coarse mass that was coming into the system from outside, and it was only removing about 20% of the fine mass, the fine particles that were coming in from outside. And so they now have an understanding of the type of dust that is coming into their system, where it's coming from, and they can now develop strategies that are targeted specifically for their museum. And likewise, hopefully the information that I provided for you today can provide you with the tools necessary to at least ask the right questions to try and understand your specific situation. Thank you very much.